All right. Here we go. The longest name of a lesson of all time right there. Simplifying expressions containing rational exponents. What in the world does that mean? Well, simplifying, we've been doing that stuff, right? Expressions, that's stuff with numbers and letters and square roots and all that kind of stuff. Okay, what do they contain? Rational exponents. What does that word rational mean? You know what exponents are. What's in the word rational? Ratio. And so what is basically a ratio? It's a fraction, right? Right? If I can compare 1 to 2, right? That's a ratio. Okay, you can do this as well, right? You've seen that before, right? Comparing 1 to 2. But that's what a fraction is. A fraction is a rational number. Okay, but we're going to talk about exponents that are fractions. Okay? So we're not going to talk about x squared. What do you think we're going to talk about? X to the, like, 1/2. Or x to the 2/3 or something like that. So that's what we're doing today. All right? So we're going to simplify some things, and they contain rational exponents, which means our exponents are going to be fractions. They're not all going to be fractions, but a lot of them are going to be fractions. Okay? Does that make you feel better or worse about what we're going to do today? Probably. All right, so this is, if you look in the book, this is example 8. And it's in 3 parts. There's A, B, and C. All right, so let's do A first. Let's just start off with an example. Because the rules that we're going to use are the same exact rules that we've always used, right, for multiplying and things like that. I tell you what, before I do the example, let's put this up here. Let's just do a little bit of, I don't know, backstory kind of stuff here. So what if I said x squared times x to the 5th? What does that equal to? X to the 7th. What did we do to the exponents here? We added them together. Okay, we added them together. So when you're multiplying with the same base and you've got exponents, you add the exponents. You keep the base the same and you add the exponents. Everybody with me on that? What if I had this? What if I had x to the 9th over x to the 3rd? X to the 12th. So you're saying that this is the exact same thing as doing this. This is multiplication. This is division. You're saying the rule is exactly the same. That would be incorrect. What's that? X to the 6th. So what did you do with the exponents this time? You subtracted them. Okay, so when it's division, and you got the same exponents, you subtract the exponents. So that would be x to the 6th. All right, we've done this before. This is old stuff. You did this in Algebra 1, for goodness sakes, okay? But here we are, and we're still not remembering it. Okay, I'll shut up and keep going. Let's see, what else could we do here? Oh, let's do this. What if I had x to the 4th to the 5th power? What's that going to be? So is it a trick question? It's not a trick question. X to the 20th, okay, because there's a rule. It's called the power rule. Look back on one of the videos. We talked about it on one of the videos. When you have an exponent being taken to another power, I hope everybody's listening. I got like 3 different conversations going on here besides me. When you have an exponent being taken to another power, you multiply these exponents right there. So this is x to the what? To the 20th, okay? So those are some basic rules that we should have remembered. Apparently not everybody has. But now that I showed them to you, it should come back to you. Oops. What am I doing? Let's do this. There we go. That's what I wanted. All right, so now, with all that said, let's do an example. So here it is. I'll warn you right now. It looks kind of ugly, but the rules are the same exact rules as what we did when we had just whole number exponents. And if you notice, not every one of these is going to have a fraction as an exponent, but some of them are. All right, there's your problem. And the problem says to simplify. simplify. Okay? Where do you think we're going to begin with this? Foil? There's no foiling here. Yeah, the second one right here. Okay, that's what we're going to do. Because right here, there's really nothing you can do with that, is there? Okay, so I'm just going to rewrite the first one the way it is. I'm not even going to use parentheses. All this is being multiplied together, okay? You just put a dot. You don't even need a dot, okay? If they're just right next to each other, you know what are they doing to each other. They're multiplying. So really, are those parentheses? Well, I should say this. Is the first set of parentheses necessary? No. Second set of parentheses absolutely right now is necessary because all the stuff in this parentheses is being taken to the 1/2 power, okay? Everybody see that? But let's figure out what it is. So it's x to the negative second to the 1/2. Remember what I just finished talking about? That x to the 20th one? What was it? X to the 4th to the 5th power? What do we do with exponents when you have an exponent being taken to another power? You multiply the exponents together, okay? So off to the side, this is the side of the paper right here, okay? Off to the side, what am I going to do with this and this? I'm going to multiply them together. So let's do it off to the side. You might be able to do it in your head. Oh my word, what just happened? There it goes, okay. I think I clicked a button on my pen and it made it weird. I got it working now. So I've got, no, it's not working now. Why? Oh, you got to be kidding me. I know, I don't want to have to do that though. Why is it doing that? Okay, but it doesn't do a short one. That's the weirdest thing. Let me get out of this and go back. No, I use this all the time. Okay, there we go. So -2, I don't know why I was doing that. So watch. What are we doing? What do we say we're doing to this stuff? We're multiplying them together. So what's -2 over 1 times what? 2 over 1. And what is that? It's not a 1. It's a -1. It's negative. I'm sorry. Because I put times 2. Why did I put times 2? Because I'm an idiot. All right. So it's not times 2. What is it? Times what? Times 1/2. I knew what the answer was going to be, but I put a 2 here. So this is what it is. It's -2 to the 1/2 power. So I multiply them together. That cancels with that. It's a -1. Everybody with me? So this is y to the, this is going to be x to the what? -1st. Okay? What's the y going to be? It's just y to the what? 1/2. That's right. It's just y to the 1/2. Technically, you do use the rule because this is y to the 1st. Everybody with me? Yes, sir. It's just somebody walked into a room. That's all he did, and you guys have already lost attention to you. Okay. I'm not talking to you. I'm talking to them. You don't tell a teacher to calm down. You kidding me? Calm down. You know what that's going to make me do? It's going to make me go ballistic. It's not going to make me calm down. I'll tell you that much right there. Stop. You're going to be 0 for 2 here because... All right, let's see if I can continue with this. So now this is what we have. All we did was take this to the 1/2 power. We took this to the 1/2 power. We got this. We're not finished because we can multiply the things with the same base. If you wanted to put them next to each other, I guess you could, but you don't really need to. So what's this x going to be? This is going to be x to the 2/3 times x to the -1st. What is the rule? We talked about it just earlier, and I just erased it. So what do we have? Thank you. Is this like the first time we've had every single person in this room? It very well could be. So let's do this. So what do we do with the 2/3 and the -1? Remember, if I said x to the second times x to the third, what do we do with the exponents? We add them up, correct? So what do we do with the 2/3 and the -1? We add them up. So 2/3 plus what? -1. Let's put it over 1. Okay? So let's find a common denominator, which is 3. That's a 2. Okay? Plus a minus is just going to be minus. So what's the top going to be? A 3, right? You see it? Got a denominator of 3. So this is really -3 over 3. Agreed? All right? And the reason I did that is because I have a denominator of 3. So what's 2 minus 3? It's -1 over what? 3. So what's my exponent for x? It's -1 over 3. That's my exponent. Let's do the same thing with the y's. But I'm not done with this, though. What do you notice about this? Can I just leave my answer? What's wrong with this? I shouldn't say what's wrong with it. Why is this not completely simplified? Because you got a negative in the what? Exponent, right? We just finished talking about that a day or two ago. All right? So we'll fix that in a second. All right? But let's just leave it right now, and let's do the y's. So let's add those together, right? You add the 1 and the 1/2. So it's 1 plus 1/2. What's 1? It's 2 over 2, isn't it? Plus 1 over 2. Everybody see that? So what do you get? 3 over 2. So this is going to be y to the 3 over 2 power. It looks like we're done, but we can't have a negative exponent. So we're going to have to do something with that negative exponent. Again, let's go back in time a little bit. What if I had this? What if I had, I don't know, x to the -2 over x to the 3rd? What could I do with this? I could subtract the exponents. That's true, because we talked about that earlier. But here's another little trick to this. If I have a negative exponent, what can I do? I can take it, throw it down to the bottom, and then do what to it? Make it a x to the what? To the +2. Okay, if I take this, chuck it down to the bottom, I change the sign of the exponent. I don't understand why people aren't watching up here. I got like 5 people looking all around, talking to each other. Why are you making me yell at you so much today? What's going on? You guys are actually usually pretty decent. So let's pay attention, because I could guarantee you, when you start working on this homework, you're not going to know what you're doing. Okay, and it's going to be the ones that are looking and talking to each other. You're going to be the ones that aren't knowing what to do. I don't know. Okay, enough. I stopped. So what's going to happen here? If this thing goes to the bottom, I'm left with a 1 up here, and then I can just add those up. That's x to the 5th. So that's what that would have been. So with this, I'm going to take this. I'm going to put a fraction. I'm going to take this, chuck it down to the bottom. If I chuck it down to the bottom, what do I do with that exponent? I make it a positive. Okay, I take it from a negative exponent. I make it to a positive exponent. That's basically done. Looks kind of ugly right now. Let's make it look a little prettier. So it's y to the 3/2 over x to the 1/3. Okay, and that is simplified. So that's this. That's the only answer that I'm going to accept. That's it. Also, don't do this. Do you see how it's y to the 3/2? Some people may say, oh, 3 over 2. That's the same as what? 1.5. We do not, listen, we never make an exponent as an improper or as a mixed number. Okay? We never go y to the 1 to the 1/2 power. Everybody understand that? So keep it improper. Improper is fine. When you're in elementary school, teachers had a fit, didn't they? If you kept your answer as an improper fraction, all right? But when you get up to doing algebra, it's fine. It's sometimes it's preferable, okay, to keep it as an improper fraction. And in this case, it's definitely preferable. All right? So keep it y to the 3/2. There are times for mixed numbers. I'm not saying mixed numbers are bad and it's just an elementary thing. But in algebra, most of the time, I would say most of the time. There are some times, yes, you want to make it into a mixed number. But I would say most of the time, you keep it improper. I just said, sometimes you will. Okay, so sometimes you will. Sometimes you leave it mixed number, or improper, I'm sorry. Yes?
So if you get an improper, right, as the answer, you always want to flip it to a...
No, I didn't flip it because it's improper. This one wasn't improper. This was to the negative 1/3. Every time you have a negative exponent is when you flip it. Okay? It has nothing to do with being an improper fraction. Okay, it has something to do with being a negative exponent. You're welcome. Thanks for asking a question and not having to go to the bathroom. All right, let's do another one. You ready for this? This is part B. 2x to the 1/3 over y to the 2/3. And that whole thing is to the negative third. There it is. Write it down. We do. We do. A lot of people might look at this and say, I'm going to take everything to the negative third power. I would not do that. Can you do it? Yes, you can. I don't think it's the best way to approach this problem. Okay? Again.
Just like how it said, if we flip it, wouldn't it make it a positive to the third?
It would. Okay, so let me give you a little thing right here. Watch. If I say 2/3 to the negative second power, we'll make it easy. Okay? Everybody watching? So you're allowed to do this. And we talked about this. We talked about this in this class. We said if you have a fraction to a negative exponent like this, what we can do, instead of making it a negative exponent, we can actually flip the fraction and then change that from a negative exponent to a what? To a positive exponent. Everybody see that? So you're allowed to do that. So guess what we're going to do here? Do the same thing. We're going to flip it and then change this to a positive third. All right? So now what's going to go on top now? Y to the 2/3, and on the bottom is going to be 2x to the 1/3. Okay? It's still in parentheses, but now it's not taken to the negative third power. What's it taken to? To the positive third. It's a lot easier to work with a positive 3, wouldn't you agree? I think so. Now, if you wanted to, you could have made this 2 to the negative third, and you could have made this x to the 1/3 to the negative third, and the same thing down here. You could have done that, and if you did it properly, it would work. It's just not as easy. I think this is a little easier. So now, let's use some of the rules we just talked about. This is y to the 2/3 to the third. So what do we do with the exponents in this situation? Multiply them together. So off to the side. Now, some of you might be able to do it in your head, and that's fine. Just write it down. Okay, but some of you are not going to be able to do it in your head. You're going to have to see it. So I'm showing you. So 2/3 to the third, that means you multiply them together. So it's 2/3 times what? 3. 3 over 1, right? And now, what happens? A lot of you are going to say 2 times 3 is 6, but what can you do a lot easier than doing that? The 3's cancel out. And what are you left with? Just a 2. It's a 2. 2 over 1. So what's my exponent then? It's y to the second. So y to the 2/3 to the third is the same thing as y squared. All right? We just took 2/3, multiplied it by 3. And some of you guys will be able to do this in your head. You're going to see that 3 over 1. You're like, oh, that 3's canceled. Boom, 2. Okay? Not everybody can do that in your head. If not, over off to the side, you write down the multiplication, figure it out. We good? Yeah. All right, let's do the bottom. Now, everything in this parentheses has got to be taken to the third power. Everything. So even the 2. So we got to take 2 to the third power. Let's do that in our head. That's right. It's 8. 2 to the third is 8. Okay, I skipped a little step, but off to the side, 2 to the third, that's 8. So I put an 8 right there. What about this one? X to the 1/3 to the third. Again, a lot of you should be able to look at it and just do it in your head. If not, let's write it down. So what do? We multiply 1/3 times 3. So 1/3 times 3, what's that going to equal? It's 1. That's right. Those cancel out, and it's equal to 1. All right, so this is going to be x to the what? Oops, tag on it. It's going to be x to the first, or just x. And that is how you're going to leave your answer. There's no negative exponents now, right? So I don't have to flip anything anymore. I already did my flipping right here with that negative exponent. And that's your answer. So really, the stuff that we're doing today isn't any different, is it, than what we've done in the past with just these regular whole numbers as exponents. Well, this might seem a little easier because we've already done this stuff before. Before, you may have learned it for the first time. So yeah, this might be a little bit easier for you. Okay, except all you're doing is just multiplying fractions and adding fractions. All right, but for some of you guys, that's pretty tough. Let's do one more. You ready? Last one. So it's 9x squared y to the 1/3 over, oops, let's make that a little straighter. That wasn't much better. X to the 1/3 times y. This whole thing is being taken to the 1/2 power. Now, there's something that's going to be kind of new. I think we might have talked about it the other day, but it wasn't like officially taught in the book. But I think we talked about it a little bit. But let's do this. Now, do I have to flip anything? No, why not? I got no negative exponents. That's right. They're all positive exponents, so I don't have to flip anything, so that makes things nice. So basically, all I got to do is just take everything to the 1/2 power. So let's take everything in here. The 9, the x squared, the y to the 1/3, the x to the 1/3, and the y. I'm going to take all that stuff to the 1/2 power. So I'm going to write 9 to the what? 1/2 power. Does anybody remember what that is? A number to a fraction exponent? I think I talked about this before. So watch. If you have, we'll use x. If I say x to the 1/2, we have a definition that we learn in algebra. Say it. Well, no, it's not really a word I'm looking for. I mean, what do we do with this? I'll just show you. Yes, exactly right. It's a square root. Okay? So here's a little definition for you. Anything to the 1/2 power is just the square root of that base. Okay? So what's 9 to the 1/2 power? It's the square root of 9. And what's the square root of 9? It's 3. So if you wanted to, you could just make that a 3 right now if you want. We'll do that in the next step, though, okay? This is off to the side stuff. All right, let's do the rest. Let's do this one in our head now. X squared to the 1/2. What do we do with the 2 and the 1/2? Multiply them together. It's 2 over 1 times 1 over 2. What's that going to give us? It's 1. So it's just x. X to the first. If you want to put a 1 there, if that makes you feel better, that's fine. Put a 1 there. Okay, what about this y? Y to the 1/3 to the 1/2. Again, what are you doing to the exponents? You're multiplying them together. In your head, what's 1/3 times 1/2? 1/6. That's it. Can you do that in your head? I hope so. You just multiply across the top, multiply across the bottom. Okay? Let's do the bottom. Here we go. X to the 1/3 to the 1/2. Same exact thing, isn't it? Except now we got an x. So it's going to be x to the 1/6. And what about this y? Y to the 1/2. You with me? Wasn't so bad, but I'm not finished. Right? I got x's on the top and bottom. I got y's on the top and bottom. Can't do that. So, let me see. What's the best way to do this? Yeah, let's just do it like this. Do you remember that rule? I'll review this again. Watch. What if I had x to the 7th over x to the 5th? What's the rule for the exponents? No, they don't cancel out. I mean, you could think of it that way, but you subtract them. Okay, that's what I want to think of right now. Okay, everybody see that? Remember the rule for division? Subtract the exponents. So this is x to the what? 7 minus 5, which is x to the 2nd, right? Now this is the same exact rule, except the subtraction's a little bit more difficult, just a little bit more difficult than just going 7 minus 5. So let's do it over here. By the way, what's the 9 to the 1/2? That's a 3. Now, let's do this right here. So this is the same thing as x to the 7th over x to the 5th, kind of. Would you agree? So what do we do with the exponents? We subtract them. So off to the side, I'm going to go 1, I'll put it over 1, minus what? 1 over 6. 1 over 1 is the same as 6 over 6, isn't it? Minus 1 over 6. What's that? It's 5 over 6. Okay, so it's going to be x to the what? 5 over 6. See it? So I just subtract the exponents from each other. The rule is exactly the same as it is here, except you're just subtracting fractions, right? We just have never done that before. Okay, this is the first time we've subtracted fractions like this. Now let's do the same thing with the y's. What are we going to do with the y's? If I could get my marker to work. We subtract those from each other. Let's just do that right here. So it's going to be 1/6. And you always take the top minus the bottom, by the way, okay? It's always the top one minus the bottom one. What's my common denominator here? 6. 6 goes into 6, 2 goes into 6. That's my least common multiple, okay? Now, what did I do to 6 to get to 6? Just multiplied it by 1. What did I do to 2 to get to 6? Multiplied it by 3, so I multiply that by 3. And what is that? 1 minus 3 is negative 2 over 6. Let's simplify it. That's what? Negative 1/3. That's just subtracting fractions. I can't take a long time to do that. This is something you were supposed to learn in 5th grade, okay? So it's negative 1/3. So what's my thing? It's going to be y to the negative 1/3. Little problem. I can't circle it just yet. What do you see, Nesia? That's right. You're going to have to take this y and throw it to the bottom because you can't have a negative exponent. So we're almost done. This is the last step. It's 3x to the 5/6 over, what's this going to be? Y to the positive 1/3. That is going to be your answer right there. What's that? That's it. What do you think? It's not hard. It's not. Well, if you'd listen at least 10% of the time, you might catch on a little bit. Now you listen about 3% of the time. Abu, stop with the ooh thing. All right. Okay, your homework. It's on your what do you call that thing? The lesson plan. But it's 55. You're basically just picking up where you ended off on the last homework. But you're going to 73 and you're just doing the odds. And it's page 78. Page 78. I want this done by tomorrow. Okay? Nah, just stay there. All right, so there you go. That's your homework. You got 5 minutes. You got 7 minutes. Okay? Let's start on it. At least get a couple problems done. Do number 55, 57, 59. Get them done before you get out of here. All right? You should be able to do 3 problems. So if you open up your book and start right now, you got plenty of time to get at least 2 or 3 problems finished. That's due tomorrow.